Okay, class, in this lesson, we are going to learn to multiply and divide rational expressions. So let's go ahead and get started. First, we're going to start with some basics here. And if you recall, if we were to simplify this fraction 12 over 16, what we would do is find factors of 12, and that would be 3 times 4, and then list the factors for 16, and that's 4 times 4. And then what we see is that there's a 4 in both the numerator and denominator, and so we would go ahead and cancel those out and simplify this fraction down to 3/4. Okay, so this process that we just went through with simplifying a fraction is what we will do with rational expressions. So let's go ahead and start with example number 2. So here we've got two sets of polynomials, and the first thing that we want to do is simplify this or factor out a greatest common factor. Okay, and so if you take a look at these three terms, we see that all three terms have an x in them. Same thing with the denominator, right? There's an x here, there's x there, and there's an x there. So if we go ahead and factor out the x's, in the numerator we get x squared minus 5x minus 24. And then the denominator, same thing, we factor out an x, and we're left with x squared plus x minus 72. Okay, so now at this point, you should recognize that the polynomial inside the parentheses is factorable. So we can go ahead and set this up. I like to set up my structure here. Okay, and same thing in the denominator. I'm going to set that up because that polynomial in the parentheses is also factorable. Okay, so here what we want to do is find factors of -4 such that when you add the factors together, we get a -5. Okay, and what we find is that -8 and +3 are factors of -24, and when you add -8 and 3 together, we get the coefficient of the middle term. And then down in the denominator, we find that the factors of -72 would be +9 and -8. 9 times -8 is my -72. When you add those numbers together, 9 and -8, we get a +1. Okay, so now at this point, we can go ahead and cancel. Let's see here. We have an x minus 8 up here and an x minus 8 down here. So we can go ahead and cancel that out because they come out to 1. And then we also have an x up here and an x down here, so we can go ahead and cancel those out. And so what that means is we're now left with x plus 3 over x plus 9. Okay, so that ends up being our answer, but we also need to be a little bit more thorough in our answer in that we have to specify what possible domains are for this expression. And so we would identify the x values that cannot exist. So in other words, if you take a look at this expression here, we would find x values that make this denominator 0. Okay, so if x were 0, this would make the denominator 0. If x were -9, it would make this 0, and if x were 8, it would make this whole thing 0. And the reason we're looking for zeros is because you can't have a denominator with a 0 value in there, because if we do, it's no longer a rational expression. Okay, so we would say that this answer would be x plus 3 over x plus 9, where x does not equal to 0, -9, or 8. Okay, and so this becomes our answer. Okay, so let's move on to the next example. Here we're going to simplify a rational expression, and the process for doing this is very similar to what we just did. What we need to do is first factor this out. So the numerator, we would see factors out 2 plus x and 2 minus x. And in the denominator, we would see that that polynomial factors out to x plus 5 and x minus 2. Okay, now at this point, it's hard to see if there's anything that's cancelable, okay, but we do see that we have a 2 minus x and an x minus 2. They're kind of close. What we could do is factor out a -1 out of this, okay, and let's see what happens when we do that. So I'm going to just rewrite 2 plus x And now I'm going to factor out a -1. And when we do, what happens to the last term is that it becomes x minus 2. Okay? And that's going to be all over x plus 5 times x minus 2. Okay. Now, if you think about this, if we were to multiply this out, -1 times x is a negative x, which is exactly what this is. And then -1 times -2 is a positive 2, which is what this is. Okay? So factoring out a -1 allows us to flip this around. So now we have an x minus 2 in the numerator as well as that in the denominator. So we can go ahead and cancel that out. Okay? And so our final answer is going to be, and I'm going to go ahead and multiply the -1 across the 2 plus x. And so we get -2 minus x over x plus 5. And then we need to specify our domain where x does not equal -5 or 2. Okay? A -5 makes this denominator 0, and a positive 2 makes this denominator 0. So this becomes our answer. All right. Now, here's another example where we're now multiplying rational expressions. And multiplying rational expressions is exactly the same as multiplying fractions. And what I mean by that is when we multiply rational expressions, or fractions for that matter, we're just multiplying across the numerator, and then we also multiply across the denominator. Okay? So when we do, we end up getting 6x cubed y over 4yz squared. Okay? And that simplifies out to, well, let's see. We have a y up here and a y down here, so we can cancel those out. And we also have a 6 up here and a 4 down here. 6 and 4 have a common factor of 2, so that cancels out to 3x cubed over 2z squared. And then we just need to specify the domain where, well, what values can the denominator not be? Well, z cannot be 0 and y cannot be 0. Okay, so where z does not equal 0 and y does not equal 0. Okay, so that is our answer for this expression. Let's take a look at part B. Here we've got a bunch of polynomials, and before we go ahead and multiply this all out, we should simplify first. Okay, so by doing that, this expression simplifies out to 5x over x plus 3 times, and the numerator of the second fraction factors out to, let's see, x plus 3, x minus 2, and that is all over x plus 1 times x plus 1, okay? And then the last fraction, that factors out to x times x plus 1, all over 5 times x minus 2, okay? All right, so now we can start canceling things out. We have a 5 up here and a 5 down here, so that cancels out. We also have an x plus 3 and an x plus 3 down here, so we can cancel those out. We have an x minus 2 up here and an x minus 2 down here, so we cancel that out. And then lastly, we have an x plus 1 here and an x plus 1 there, so we can cancel that out. Okay, so rather than multiply all of this out first, we simplify, and we see that it makes this simplification a lot easier. Okay, so this comes out to x squared over x plus 1, where x does not equal -1 or 2. Okay? All right, and that is our answer. Now, let's move on to the next example. Here we're going to multiply a rational expression by a polynomial. Okay? This is the same thing as multiplying two fractions together. And what I mean by that is this comes out to x plus 2 over x to the 4th minus 16 times, and then the polynomial just sits up here, plus 4x squared minus 12x, and that's all over 1. Okay? So now that we have it set up this way, we should be familiar with how to do this. So we're going to go ahead and find the greatest common factor here, and we're going to factor this out as well. So this comes out to x plus 2 okay, all over x squared minus 4 times x squared plus 4 times greatest common factor for the second set of polynomial is x, and when we do factor out the x, we get x squared plus 4x minus 12. That's all over 1. Okay, we're almost there, but we're not quite there because we could still factor this polynomial, and this could be also factored further. And so this becomes x plus 2 all over x plus 2 times x minus 2 times x squared plus 4, okay? And the polynomial inside the parentheses for the second set comes out to x plus 6 and x minus 2, all over 1. All right, so now we can start canceling things out. We have an x plus 2 and an x plus 2, so we can cancel that out. We have an x minus 2 and an x minus 2, so we can cancel that out. Okay, and so we're left with x times x plus 6 over x squared plus 4. Okay, and then specifying the domain where x cannot equal -2 or 2. Okay, again, finding these values is all about identifying x's that make this denominator 0. So if this were a -2, this makes this quantity 0, which makes this whole expression 0. And if x were 2, it makes this whole thing 0, which makes the denominator 0. Okay? So then this becomes our answer. Okay, moving on to the last example. Here we are now dividing rational expressions. Dividing rational expressions is actually fairly straightforward in that all we need to do is multiply by the reciprocal. Okay, so what do I mean by that? I'm going to go ahead and rewrite this as x squared plus 2x plus 1 over 1 minus x squared. And then instead of dividing, we're going to multiply, and then we're going to flip the next set of fractions. So this becomes x squared plus 3x minus 4 over x squared plus 5x plus 4. Okay? So what you'll see is this denominator is now this numerator is now the denominator, and then this denominator is now the numerator. So we flip that around, and once we do that, we can go ahead and factor each of these polynomials. So this is factorable, this is factorable, this is factorable, and this is factorable. Okay? So this should come out to x plus 1 times x plus 1 over 1 minus x times 1 plus x. And the second set should come out to x plus 4 and x minus 1. And the denominator should factor out to x plus 4 and x plus 1. Okay? So now we can start canceling things out. We have an x plus 1 here and a 1 plus x, which is really x plus 1. So we can cancel those out. Okay, that cancels out. We have another x plus 1 up here and an x plus 1, so we can cancel that out. We have an x plus 4 up here and 1 down here, so we can cancel that out. Okay, and then lastly, we have an x minus 1 and a 1 minus x. That really comes out to x minus 1 on the numerator, and the denominator we can factor out a -1, and that comes out to x minus 1. Okay, so now that we have an x minus 1 up here and 1 down here, we can go ahead and cancel that out. And our final answer ends up being 1 over -1, which is equal to -1. So all of this simplifies down to -1. And then we just have to specify our domain where x does not equal 1, -1, or -4. Okay? So hopefully this makes sense. I know I went fairly quickly when it comes to factoring, but by this point, factoring should become more second nature. If any of this was confusing, or you just need to go through this again, please go back to the beginning of the recording and listen to it again. Thank you.